a student of B.Tech Electronics Engineering in VIT Vellore.
Good afternoon, I'm Neha Banerjee. I'm a B.Tech student, a final year in Electronics and Communication Engineering, and we are doing our project under Professor Aarthi ji. And this is our project. Solar tracking system.
The topic of the project is solar tracking using STM32 and IoT integration. For this, we have used various different components, the main components being the STM32. Then we have used the ESP8266 module. Then we have used the solar panel, and along with the solar panel there are two LDRs which track the light sensitivity. To move the solar panel, we have used a servo motor. And the servo motor, to get the energy from the solar panel, we have used an INA module, INA 219 module. So what this thing basically does is, the STM32 is calibrated to sense the light intensity from either of the two LDRs. Whenever the light intensity of one LDR sensed by one LDR is more than the light intensity sensed by another LDR, it moves towards that LDR. So if this LDR senses more intensity, then the solar panel will move this side. If this LDR senses more intensity, the solar panel will move that side. This has been done so that based on the orientation of the source of the light, we can always have the maximum amount of light incident on the solar panel. And the solar panel, so we are getting light on the solar panel with the maximum intensity. Now the solar panel is connected to the INA 219. What the INA 219 does is, it gets the values of voltage, current and power from the solar panel. So the solar panel is getting some light, it is generating some potential, and based on the potential we are getting voltage, current and power values, and then the INA is sending those values back to the STM32, and we can display the value that we are receiving of the voltage, current and power values under the terminal of the STM QID. Now the second part is the IoT integration part. What it is doing is, the values received by the STM32 is being sent to the ESP8266 module. Now the ESP8266 module is not doing anything separately. It is just receiving the values got from the STM32 and sending it to a cloud platform. Now we have used Adafruit IO for this, but we can use ThinkSpeak, Blink or anything else. Now we shall show the working of the circuit. So the solar panel is currently tilted upwards, and the only part that we are given to the circuit is the STM32, which you can connect to a laptop or any other electronic device. So the laptop is enough for giving power to the STM32. We shall connect it. The only part the whole circuit needs is the power to the STM32. We can see through the green light that the STM32 is powered up and running. Because there is enough power to the STM32, subsequently the connecting peripherals are also working, like the INA, the ESP and everything. See, the servo motor is already up and running, and now if we put light on top of the solar panel, it moves in the direction of the LDR that senses the more light.
So now we'll head towards the result analysis. The first one is Simulink output for PWM signal for DAB. The next one is STM QID output for the movement of the solar panel. It is showing voltage, current and power respectively. This is from a cloud platform called Adafruit IO. This output is when the panel turns rightwards for flashlight. Similarly, this output is when the panel turns leftward for flashlight. And this output is for sunlight. Thank you for watching this video.